Finding the derivative using an implicit curve, finding y prime, involves two different steps. The first step is to actually take the derivative of the equation, and that's what we did on the last slide. We took an equation which involved both x and y, and we differentiated it. We took the derivative of both sides. After we've done that, we still must solve for y prime. To solve for y prime, we first must rearrange the equation to get all the terms of the y prime on one side and all the terms without a y prime on the other side. Then, all the terms of the y prime are going to be the same side, so we can factor y prime out of all those terms. And then we're going to be left with y prime times something complicated. We can divide both sides by that something complicated to solve the equation. The result of this procedure will always be a formula for y prime in terms of both x and y. We can't in general reduce this to a formula only in terms of x, because if we could likely also solve for y in terms of x. In that case, it would not be an implicit curve, it would be an explicit curve. So usually with implicit differentiation, our final answer, our result for y prime equals, will always have both a y and an x in it. So now I'm going to do a couple examples of finding y prime using implicit differentiation. So in this first example here, we have an implicit curve and we want to find y prime. So we're going to start by taking the derivative of both sides. The derivative of e to the y is e to the y times y prime. That's using the chain rule. We want to do the derivative of x squared y. We're going to do the derivative of the first, which is going to be 2x, times the second, which is y, plus the derivative of the second, which is y prime, times the first, which is x squared. And then on the right-hand side, the derivative of y cubed is going to be 3y squared times y prime. Again, that's using the chain rule. So now we want to put all the terms with the y prime in it onto one side of the equation. Well, there's one already on the right-hand side, so we're going to move the other two to the right-hand side. So on the left-hand side, we're just going to be left with 2xy. On the right-hand side, we're going to get 3y squared y prime minus e to the y prime minus x squared y prime. So now we want to factor out a y prime out of all those terms on the right-hand side. So y prime times 3y squared minus e to the y minus x squared. This whole thing equals 2xy. So we're going to divide by this thing, and we get that y prime is 2xy over 3y squared minus e to the y minus x squared. So we have solved for y prime.